Let us now discuss the oxidation states of halogen. Oxidation state, the -1 or +1, +3, +5, +7, these are all the various oxidation states exhibited by halogen. But predominantly the fluoride it exhibits -1 oxidation state. That indicates it's a very strong oxidizing agent. Just look at the electronic configuration. As we know already, the halogens, they have the general electronic configuration. What is that? NS2 NP5, is it not? This NS2 NP5, in the case of fluorine, it is a 2s2 2p5 after helium, is it not? So that is the way we write down the electronic configuration based on the inert gas. And when we look at chlorine, it is 3s2 3p5. So here we have NS, so 2 electrons. And what about this p orbital with the 3 boxes, p orbital, that is NP5. And there is no d orbital in fluorine, and that is why it has got an unique nature. We call the anomalous behavior of fluorine. And so that is, since only one electron is there, either it has to accept one electron or release one electron. So by accepting one electron, it can easily attain the octet configuration, is it not? Because it has got already 7. So taking one electron inside and thereby getting the stability is very, very comfortable for halogen. So in the case of fluorine, that is why we have the -1 oxidation state, and that is very, very popular. And that is why it is a very good oxidizing agent also. Then, and that is why this fluorine is capable of oxidizing other halogens also. When you combine any halide with the fluorine, then it becomes what? What do you mean by, see, that is, it is a strong oxidizing agent means what? Strong oxidizing agent means it should undergo reduction. What do you mean by reduction? In terms of electron, addition of electron or removal of electron? Anyone?
Addition of electron.
Very good. So addition of electron. So this F is capable of getting added, that is adding with the electron. So F minus. So F, what is the oxidation state of fluorine in the neutral molecule? 0. So it becomes a minus, means it undergoes oxidation, reduction. When it undergoes reduction, then it acts as an oxidizing agent. I hope now you should be able to understand this equation. That is why it is a very powerful oxidizing agent, this F2. So it is capable of oxidizing other halides also, and thereby it becomes a fluorides, and it makes the halide ions into halogen molecule. Okay. So suppose if I take any chlorine, it becomes chlorine gas. When I take any bromide, it becomes a bromine gas. So likewise it goes. Okay. So that is the speciality of this fluorine. I hope now you should be able to understand. That is because of the electronic configuration, where you have got the unpaired electrons on the outermost shell of fluorine, and not only that, in the p last orbital. It is unshared, unpaired. Okay, right. So that is capable of pairing by taking one electron. And then what about the +3 oxidation? When it loses one, it becomes a +1. Then in the case of +3, so now on excited state, it can become, the one electron can go over there, so that you are able to get what? It can jump over to d orbital. You may ask me, sir, why not in fluorine? because there is no d orbital for fluorine. Whereas in the case of chlorine, there are some empty shells of a d orbital, so it can occupy that one. So it becomes what? 1, 2, 3. So it can leave 3 electrons. It means 3 plus oxidation state is possible. And similarly, one more electron can jump over in the next stage, as in the case of a fluorine, chlorine, bromine. So now you are able to get what? That is 5 oxidation state, plus 5, because 5 electrons can be lost. 7 electrons can be lost in this case, so it can attain plus 7. So in the case of iodine, it can. So likewise, it has variable oxidation state. I hope now you should be able to understand. You please go through that, and you should know how to fill up. Please go through. Got it?